Let's go ahead and get started, and we're going to try to make this as lively a session as we can to overcome the effects of lunch. And a couple of quick announcements. These are the last two sessions, or the last set of sessions this afternoon. Then there's a keynote. We've just been downloading a number of new presentations, so if you don't have a copy of this, you can download it now. We do have an announcement to make, which is there was a speaker that was going to be talking today on expertise location, and due to legal concerns, they are not going to be here. So luckily, we found a speaker that is going to be here and that has done work in expertise location, and they've decided they can fit in. And of course, it was pretty easy to find because it was me. So I'm going to go ahead and introduce myself again. No, I think if this is your first presentation, then you're probably out of luck. But I've been introducing myself a number of times today, so I won't bother again, particularly since we were already running a little bit late. What I'm going to do today is talk about an approach to expertise location, or a technique that can be used in expertise location along with other techniques. And then the second half, we're going to have Paul Thompson here as an instructor at Dartmouth, talking about anomalous states of knowledge, and also in this whole general theme. So with that, let's go ahead and get started. So we've already done the introduction. What I'm going to talk about is what's called basic level categories, and it's based on some research that was done, actually started about 30, 40 years ago, and there was one other speaker yesterday that mentioned it, so we're going to go into a little bit more detail. Basic level categories are a way to really characterize, among other things, expertise. And so we're going to talk about what are basic level categories, what are the features, and then talk about how you can use basic level categories in expertise location and other kinds of analysis. What we'll probably do is what we've been doing so far because of the time constraints. Maybe there'll be one question at the end of this if you've got them. Otherwise, we'll wait till the end of the two combined sessions. Okay, so what's a basic level category? It's a concept that was developed. It's something that taxonomists should know, and people in text analytics should know as well. If they don't, they should read up on it. It's basically a lot of characteristics of a basic level category. Number one, basic levels, it's not the top, it's not the bottom. They tend to show up in mid-level of a taxonomy. There's three different basic levels that you can talk about in this particular theory, and the idea is that it's like a triple, but it's not subject, object, predicate, but it actually has some of the same characteristics of a triple. As you can have sets of triples of subordinate, basic, or superordinate, basic, and subordinate. What do we mean by that? Well, the simple example would be you have mammal, subclass is dog, subclass is golden retriever, or furniture, chair, kitchen chair. And the idea is that the middle level, the basic level, is, in this case, dog or chair. The characteristics of basic level is that a basic level concept is basic in 4 dimensions. Perception, you tend to see an overall shape. You have a single mental image associated with it, and it's a very fast identification. So we can see a dog. We can't see a mammal. We can see a golden retriever, but then we'll get to that in a second. But one of the characteristics is you can see it as a single object and very fast identification. Other is that it tends to be associated with a particular motor program, a functional area, but more importantly from our perspective, text analytics, it's in communication issues, it tends to be the shortest words, tend to be very commonly used, and most importantly, or not for psychology perspective, it's the first word learned by a child. So for example, children do not learn, oh look mommy, there goes our mammal, right? No, this dog, cat, I mean those are the words that they learn first. For knowledge organization, what's critical about it is that this is where most of the attributes are stored in this basic level. And it's also where you find the maximum balance of distinctiveness and expressiveness. And what we mean by that is expressiveness is the number of properties associated with it, and distinctness is how easy it is to tell one from another. And so these are the characteristics of a basic level category that really are important for text analytics and for taxonomy development. So how do you recognize a basic level? And this is something that we'll also be looking at later. There's a measure that's been developed called Q validity, which is the probability that a particular object belongs to some category given that it has one of the properties. If something has wings, you can calculate the probability that it's going to be a bird. Okay, so this is one of the ways you can recognize a basic level. As I mentioned before, they tend to be short words or short noun phrases. The kinds of attributes associated with them are different. All of this has a great deal to do with not just expertise location, but fact extraction, entity extraction, and so forth. So superordinate, for example, they tend to be functional categories or attributes. For subordinate, tends to be adjectives. So, for example, again, a golden retriever has specific types of adjectives associated with it. And then basic level has collections of properties. And so that's another way to recognize that you're looking at a basic level category. And the point is that we can make rules, we can build categorization type rules to take advantage of this. The one issue, though, is that for objects, this is a very, very powerful technique. It's a little more complicated for non-object domains, but it's still a theory or a concept that can be used, say, throughout text analytics, and specifically, as we'll see, for expertise location. One of the issues associated with using this as a technique is that what is basic can be very context dependent. I'll show you an example as we go on. So basic levels are really a relationship. So there's not like this is the basic level for all objects in the universe, but rather within this domain, this is what the basic level would be. So each time you change the domain, you have to identify the basic level. Okay, the other levels, subordinate tend to be more informative, but less distinctive. So for example, in a basic level, you've got, say, dog and cat. Those are very distinct. You can tell the difference between a dog and a cat very easily. Telling the difference between a golden retriever and a golden lab is much more difficult. So, so the basic level has both of those. The subordinate level, you have a lot of properties associated with, say, a golden retriever, but not as distinctive. They tend to have basic shapes associated with them. They tend to be very functional, focused, and with additional details added to that. And the convention is, both in text and in person, people identify something at the basic level unless there's some reason for identifying a higher level or a lower level. So the basic level is where you can find most of the words in text and also in conversation. For superordinate, it's the opposite. They're more distinctive. Again, mammals from reptiles are pretty distinctive, but there's not as much particular attributes associated with the superordinate level. Very often, they're collections of things. Like furniture is a whole collection of various kinds of things. They often refer to mass nouns rather than things that you can count up. And when you try to build, for example, categorization rules, you tend to focus on very abstract functional properties. This is a level that's very, very hard for children, for example, to learn. Learning the difference between a mammal and a reptile is something that comes way later in life than when you can identify a dog and a cat. So those are some of its properties. So what does all this nice, strange theory have to do with us, with doing text analytics, with taxonomies, or in this particular instance, expertise location? There's a lot of characteristics associated you can use to build models about expertise. And one of them is that experts tend to prefer the lower levels, not the basic level or the higher level. And novices tend to stay at the high level. They're more general words. And the general populace prefers the basic level. Again, these are tendencies. These aren't hard and fast rules, but that's basically one thing you can do. For example, if you're looking at a paper that's been written by an expert, like say in healthcare, the word healthcare and similar sorts of words almost never show up. They're looking at the very specific lower level words, and and using the amount of specific low level words is one way to build an expertise characterization. And you can build these kinds of expertise characterization for individuals based on the documents they've written, for example, for whole communities based on the documents you see being passed back and forth around the committee or the community. You can do it for individual documents. Is this written by an expert or not? You can build these rules that look and can characterize how expert a particular document is or a set of documents. Other characteristics have to do with the type of rules that you see. Experts tend to chunk things into series of actions. They don't talk about the things so much as the processes associated with them. Again, you can distinguish that from novices that tend to look at very high level. They talk about healthcare rather than individual processes, for example, within them. And they tend to focus on the individual steps. The other aspect of this, though, is very often experts also tend to speak in a special language that non-experts typically don't understand. That specialized language can be captured and used as well. So, how do you do this with expertise location? What are the kinds of things you can do? Well, as I mentioned, one is that what is expert is corpus context dependent. So, for example, if you've got a collection of documents that are about, scientific healthcare, very precise, or more precise kinds of topics, then what constitutes an expert or expert documents within that is going to be very, very high. Whereas if you've got a general healthcare set of documents that someone has authored, then that person might be an expert in relation to a general set of documents, but not necessarily an expert in relation to a set of very highly scientific documents. So the characteristic, when you're trying to build an expertise profile, how expert is this person, it's very, very context or corpus context dependent. Which means that you have to build an overall expertise level for a corpus. Now, that's something that is done actually very often with statistical methods. You don't need to build specific categorization rules to do this, but rather you can look at the kinds of words that show up and build much more accurate, categorization rules, statistical rules. If you were listening to some of my earlier talks, obviously I have a bias towards building rules, but in this particular case, the statistical method is actually more than adequate in most cases. But then once you do have the overall characteristics, that's when you build those kinds of rules that are very much like the categorization rules that we've been talking about all along, but that I was showing yesterday. If you see these kinds of words together with these words, if you see these words in titles, then you can build these kinds of more sophisticated expertise categorization rules. So it's basically, that's what I was talking yesterday, the categorization isn't just categorizing by subject. It can be, you can categorize by a whole variety of different kinds of properties, and this would be one of them. But again, you need to have contextual rules, very similar to the disambiguation rules that we were talking about yesterday, and they were also talking about earlier today for named entity recognition. And some of the kinds of characteristics you have to look at, again, if you see the word tests, for example, if your named entity recognition just sees something that and grabs that, then it's not going to be able to do this kind of expertise categorization. And so you need to have an entity extraction component that looks like the one that Jeff Fried was showing an example today, where you're looking at collect or series or phrases and not just individual nouns for your entities. But it's also very important to realize that there's ways to do this really badly. And one way to do it really badly was done a few years ago when a group of researchers developed an automated essay evaluation program for high school students that were writing essays in their English class. The problem is that particular automatic essay evaluation was essentially using how many big words did they use. How many multisyllabic words did they use, and they didn't look at the context around those words. It didn't take long for students to realize what they could do. Throw in every big word they ever knew that had nothing to do with the topic, but if all the software was doing is counting how many big words were in there, wow, this person is an expert, they really know all about it. So it's important to not just do simple kinds of things. You have to look at the context around those words. Once you do that, some of the application areas you can do with that expertise characterization is, first of all, you can build automated expertise profiles. Once you do that, you can characterize people's expertise and then add that to things like business intelligence, customer intelligence. So instead of just asking what are people saying about my document, or what are people saying about a particular company or particular topic, what are the experts saying versus the non-experts? And for expertise location, that's another one we'll get to in a second. It can also be combined with voice of the customer and sentiment analysis applications. Again, you want to know, what are experts saying? Are they happy? Are experts more happy with your product or your new initiative than non-experts? So it adds another dimension to the analysis. So it's not just, though, sentiment analysis, what things, if you add that to looking at the specific issues. So, for example, the screen I showed yesterday where you're looking at cameras and different qualities of cameras and looking at positive and negative terms. Well, you can also look at what are the issues associated with a particular, say, product that you've brought out with a new camera. And that's good to know, but it's even better to know what the experts are saying about your new camera versus the non-experts. What issues are causing them problems? It doesn't mean that you necessarily want to focus on them, but you can at least distinguish them from what the novices are saying. And you can also characterize an entire level of expertise in a community this way. And for knowledge management, which is about half the people in the other rooms, knowledge management, expertise location is one of the very standard kinds of applications. One of the big problems with expertise location in the KM world is most of them are dependent on authors writing up a profile of themselves or somebody writing up a profile about them. It's a lot of extra work. It also has a lot of issues with, just how truthful are somebody being, or how are they inflating? Are they really under-evaluating? And so instead of that, you simply look at the documents that they've authored and create an expertise profile and an expertise characterization level for those people in the organization. It's actually it's easier to do. It gets rid of a lot of the issues you have with self-authored ones. And then finally, the last piece, which are, my group has done a little bit of this, but one of the last things I want to talk about in terms of the expertise profile is adding that Q validity calculation to knowledge graphs. We've heard a lot about knowledge graphs here. Knowledge graphs, one of the things they have really powerful is that there's no schema that you have to have. Okay, you can have, things can be related to each other in all different kinds of ways. So that's one of its powers. It's also one of its weaknesses. Because if everything can be related in all different sorts of ways, that's not how we think. We tend to think we relate things in certain classes of ways. So how do you combine, hierarchical classification with knowledge graph classification? And one of the ways is looking at relationships between sets of properties. And so if you see, again, if you see an object that, say, it has a bird and it has wings, you can then start using that to calculate what are the probability that it has these other sets of properties as well. And so you get a cluster of properties within the knowledge graph that are more closely related to each other. So that's just one of the areas that we're looking at in terms of research. So let's skip over this because I think I'm almost time. There was a talk earlier in here that talked about function words, and unfortunately I missed it, but this is something else that you can combine with expertise location, but let's skip over that since we're almost out of time. So, in conclusion, basic level categories are fundamental to human cognition. They add a new dimension to text analysis and auto-categorization. You can build expertise categorization rules just like you can build subject categorization rules, and then add a whole new level of applications. And you can generate these automatic profiles, not author-generated profiles, and combine expertise categorization with pattern-based machine learning characterizations and combine the best of both worlds. In this, something like a highly focused area like expertise, you can do both. And with that, I will stop. So, thank you.